Hi there, this is Tony Verbsky. Um, hey, my number is 720-985-1986 if you ever need to actually talk to me or, um, text me. Um, Double angle formulas are huge, so are half angle are kind of huge, but mostly double angle, they occur a lot in calculus, and you need to see one coming from like a mile away. But recall, world's worst math word, from last time, cosine of alpha plus or minus beta, this is two formulas, is sin, sin, alpha, beta, beta, alpha, minus goes with plus and plus goes with minus. And sine alpha plus or minus beta is sin, sin, cos, alpha, beta, beta, alpha, plus goes with plus and minus goes with minus. Now, all we're going to do is let beta equal alpha. So you're going to get cos of 2 alpha is, of course, cos of alpha plus alpha. And now we use the formula, which is cos, sin, alpha, beta. Whoops, not beta. Alpha, plus is minus, and we get cosine squared alpha minus sine squared alpha. Memorize it for the rest of your life. Now, that's one of them for cosine 2 alpha. Next, replace this with 1 minus sine squared alpha, and you also get a second one, which is 1 minus the sine squared minus another sine squared is minus 2 sine squared alpha. But wait, replace this with 1 minus cosine squared alpha, and you get cosine squared alpha minus 1 minus a minus cosine squared alpha is 2 cosine squared alpha minus 1. You get 1, 2, 3 different formulas. Now, I'll talk about these another time, but in calculus, we isolate the sine squared and we isolate the cosine squared. But in this class, this is the way we memorize them. They are identities. I just proved them all. Similarly, sine of alpha plus alpha, i.e. sine of 2 alpha, is sin, cos, alpha, plus goes with plus, and you get 2 sine alpha cosine alphas is the sine of 2 alpha formula. And a little more painful, but not much, sine of 2 alpha is 2 tangent alpha over 1 minus tangent squared alpha, which, if you remember the formula from last time, to be tangent of alpha plus beta, which is tangent alpha plus tangent beta, and 1 minus tangent alpha tangent beta. You can see, if you replace the beta with an alpha, how we got 2 of those and that one right there for our tangent 2 alpha formula. Now, what we do is we create the greatest problem of all time, like tangent. Come on, computer. Tangent alpha equals, Got little technical difficulties. Maybe it's my mouse. We got things, keyboards causing me problems. Let me shut this down. Uh-oh. Here, let me pause. I can do that much, maybe. I'm going to pause. All right, I think I'm back. Tangent alpha equals 5, 6, alpha and 3. Then you can draw alpha ref triangle. And you say TOA because you got tangent. 5, 6, 36, 25, square root of 61. But of course, they're going to ask you for sine 2 alpha, which is 2 sine alpha cosine alpha, which is 2. Got to figure it out. But since it's a reference triangle, instead of actually drawing the triangle in the third, you got to understand in the third, sine is negative, and cosine, oops, here we go, is also negative. And then you say so, 5 over radical 61. And you say ca, 6 over radical 61. And then we simplify to 30, 60 over 61. And we can do it for any formula. So I can do cosine of 2 alpha. I got 3 choices. I like this one, 2 cosine squared alpha minus 1. 2 something squared minus 1. But I just did cosine alpha. Cosine alpha was 6 over the square root of 61 negative. So negative 6 over the square root of 61 negative, but the negative's not going to matter because you're going to square it, and you get a 2, you get a 36 over 61 minus 1. We get a 72 over 61 minus 1. How about call that 61 over 61, and we get 11 over 61. And I can do the same thing for tangent if I want. That'd be easier, though. I wouldn't have to draw the triangle because the formula just has tangent alphas in it, and then you just use the formula. Yeah. Now, the book is getting it right after verifying identities, which I'll do later. They just want to ask you some trick questions. So here's like an example. What is cosine squared of 7x minus sine squared of 7x? Well, you know that's that cosine double angle formula, so it's cosine 14x. Oh. Oh, sorry about that. I got a text. Hopefully I don't do that too often, as bad as some kid. Here's another trick question. Sine 15 degrees, cosine 15 degrees. You know the sine double angle formula, and this happens a lot in math. You get a sine and a cosine. So sine of 2 alpha is 2 sine alpha cosine alpha. So you need a 2. So what I do is I put a 2 here and I divide by 2 and I circle this. So I know this is really sine of double this, 30, all over 2. That sine of 30 is 1/2 over 2, which is really just 1/4. I don't know why my pen changes color when I get to the edge of the screen, but it's a nice little warning, I guess. So that's fine. Now, they have another classic problem. Classic. If they give you a double angle, cosine of 2 theta equals, let's just say 5/12, and we say theta's in 2. We got 3 formulas for this guy. Don't choose the one that has both of them in there. Let's go with my favorite, 2 cosine squared of theta minus 1 equals 5/12. And you add 12/12, you get 17/12. So 2 cosine squared equals 17/12 divided by 2. Cosine squared equals 17 over 24. Cosine theta equals plus or minus the square root of 17/24. But theta is in 2, and you got all students take calculus. We know cosine in the second is actually negative. So we're good. So let's just draw a theta ref. And this is pretty ugly. You can bust this up into the square root of 17 over the square root of 24. I might wish I would have rationalized it, but I'm going to go with it. I'm going to say ka, square root of 17, square root of 24. And you square it, you get 24, you get 17, and the difference is 7. So now I got a good triangle, and they're going to ask a question like cosecant theta. Well, cosecant is CHO, therefore H over O, square root of 24 over 7. That we're in the second, so cosecant's like sine plus. Pretty awesome, huh? That's a good problem. I could ask you all of them. It's a really, really, really good problem. Now, I don't know, I haven't had much use for this, but sine of 3x, triple angle formula, I guess, is sine of 2x plus x, which is 2 sine 2x. Whoops, back her up. Now that's sine of alpha plus beta. So it's sin, cos, 2x, x, 2x, plus is plus. Now sine 2x is easy because it's 2 sine x cosine x times another cosine x, so that's squared, plus sine x. Now here's the bad one, because there's 3 choices. I don't care. Let's go with the weird one. The cosine squared x minus sine squared x. I actually looked here in my brain and saw one of those over here. That's why I went with it. Because there's 2 of them, and one more is 3 sine x cosine squared x minus sine cubed x. And I don't know what to do. We could get rid of cosine squared. I don't even know where to go. How about 1 minus sine squared? There's no good place to stop. So we're going to bring that in. So you get 3 sine x minus 3 sine cubed x minus sine cubed x, and I get 3 sine x minus 4 sine cubed x. Just in case you needed a triple angle formula or something like that. I don't know my triple angle formulas. Okay, now I think I'm going to do this in multiple lectures. So this is just was a short lecture. It looks like this section's going to pile up on me. So I'm going to stop right there. There's no way I can get it done in 40 with the amount of material they're chunking in here. So let me go back and retitle this lecture. Double angle, half angle formulas, lecture 1 of 3. All right, so that's it for today. You just know enough to be dangerous. You could start working your 10.3 MML, but just know there's a ton more in this section, and we got a ways to go. So, proceed at your own, proceed with caution.